Let's dive into one of the most powerful and, let's be honest, sometimes stressful features in Kubernetes, autoscaling. This is the magic that can take your application from a full-blown crisis to a state of perfect, cost-effective control right when you need it most.
I mean, it's the dream, isn't it? Your app just explodes. It goes viral. But that dream can become a total nightmare fast if your infrastructure isn't ready. So what really happens when that tidal wave of success actually hits?
Okay, let's set the scene. Imagine your e-commerce site is bracing for the biggest shopping day of the entire year. Every single click, every purchase, every second of uptime, it all counts. The pressure is seriously on.
And then, bam! It happens. The sale goes live and traffic just surges beyond your wildest dreams. Your application starts struggling under the load, slowing way down. Kubernetes, it tries to help by spinning up more copies of your app, more pods, but they just get stuck. They're just sitting there, useless, with a pending status. Your site is grinding to a halt.
So what's Kubernetes' first move in a situation like this? Well, it does exactly what it's designed to do. It tries to scale out the application itself by throwing more pods at the problem.
This first responder has a name, the Horizontal Pod Autoscaler, or HPA for short. Its job is pretty simple, really. It watches key metrics like CPU usage, and when things get too hot, it automatically adds more replicas, more copies, of your application pod to handle all that extra load.
And let me tell you, the HPA does not mess around. In our e-commerce crisis, it sees the CPU going through the roof and immediately tries to scale from, say, 10 pods all the way up to 40. It's an aggressive move for sure, but it's exactly what's needed to meet that insane demand.
So, the HPA has ordered up 30 new pods. They're ready to go. But where do they actually go? They have to run somewhere, right? And this is where our crisis gets a whole lot deeper.
And there it is. That's the catch. All those new pods are all dressed up with nowhere to go. They're stuck in that pending state because the servers, the nodes in our cluster, are completely full. It's like you can't put more cars on the highway if the highway itself is just a giant parking lot.
Okay, this is the moment Kubernetes makes its next absolutely critical move. Since there's no more room on the servers we have, it's time to call for bigger infrastructure. It's time to scale the nodes themselves.
So let's meet the real hero of this part of the story, the Cluster Autoscaler, or CA. Now, unlike the HPA, which scales your app, the CA scales your entire cluster. It has the power to call up your cloud provider and request brand new servers on the fly.
So here's how it works, step by step. The Cluster Autoscaler sees all those poor pods stuck in pending. It realizes there's no capacity, so it makes a call to your cloud provider and says, "Hey, I need more servers, and I need them now." The new nodes get provisioned, they join the cluster, and boom, the scheduler immediately places those waiting pods onto them.
And just like that, the crisis is over. The application is scaled out, the website is fast again, and customers are happy. But the Cluster Autoscaler's job isn't done. Oh no. When the sale ends and traffic dies down, it intelligently removes those extra, now unneeded nodes, saving you a fortune in cloud costs. That's smart.
So we've seen the HPA and the Cluster Autoscaler work together like a tag team in a crisis. But to really master this, you gotta know the whole toolkit. So let's zoom out and look at the complete picture.
There's a third key player you should know about, the Vertical Pod Autoscaler, or VPA. Now, if the HPA makes your application wider by adding more pods, the VPA makes individual pods taller by giving them more resources, like more CPU or memory. This is perfect for things like databases that can't easily be spread out across lots of copies. This table really sums it all up beautifully. You've got the HPA scaling out pods for scalability. You've got the VPA scaling up pod resources for stability. And then you have the Cluster Autoscaler, scaling the actual nodes for capacity and cost savings. Each one has a distinct and really vital role to play.
Look, knowing the tools is one thing, but using them effectively, that's a whole other ballgame. So let's get into some pro tips for getting your scaling configured just right.
Okay, first up, always, and I mean always, set minimum and maximum limits on your Cluster Autoscaler. This is your safety net against a runaway cloud bill. Second, for most web apps, that HPA and Cluster Autoscaler combo is your classic 1-2 punch. Third, and this is absolutely critical, make sure your pods have accurate resource requests. The autoscalers are only as smart as the data you give them.
And finally, use node labels to make sure specialized workloads, like things that need GPUs, land on the right hardware.
And hey, a little bonus tip for all you folks running on AWS, you have got to take a look at Carpenter. It's basically a next-generation autoscaler that can be even faster and more efficient because it picks the perfect server type on the fly based on exactly what your pods need in that moment. It's incredibly powerful stuff.
Now, I have to be really clear about this. None of this is set it and forget it. You absolutely have to monitor your scaling behavior. Use tools like Prometheus and Grafana to build dashboards so you can actually see what's happening. Are you scaling too fast, too slow? You have to use that real-world data to fine-tune everything, not just guesswork.
You know, ultimately, it all comes down to this core idea right here. You're aiming for that perfect balance, that sweet spot. You want a cluster that runs with precisely the right number of nodes, never so few that your application falls over, but never so many that you're just burning money. That is the true art of autoscaling.
And that brings us right back to our opening question. After seeing how all these tools work together, taking you from total crisis to total control, you gotta ask yourself, is your cluster really ready for its big moment? Are you truly prepared for success?